Hello everybody. The important topic on which we will be discussing is that the current source in series with other elements. Okay, so we will be discussing that if a current source is in series with other elements, so what is the equivalent circuit, and if there is a voltage source which is in parallel with some other elements, then what will be the equivalent circuit. So let's say this is one particular network. Okay, this is one particular network, and along with this network there is one element. It may be the resistance, it may be the capacitance, it may be the inductor, and along with that particular element we are connecting a current source in series. Okay, now this current source is I, let's say. So obviously we can see that as this particular current source having the current I, and this element is connected in series with this particular current source in this branch from A to B, the current is I. So if I draw the um, equivalent network, the equivalent network will be a simple current source. We can dissolve this particular element in the equivalent circuit, and we can say this is the I and this is the equivalent circuit. Okay, similarly, let's say along with the current source there is a voltage source available. Let's say this is a network, and in series with a voltage source we are having one current source. So in this particular branch the current will be I. So we can draw the equivalent circuit. We can draw the equivalent circuit like this way. The voltage source will be can be dissolved, and only the current source will be there. Okay, now let's say we are having a network like this, and we are having a element here, and in parallel we are having a voltage source, let's say V0. So obviously if I consider this particular section here, the voltage is V0 because this element and the voltage source are connected in parallel. So obviously the voltage across the terminal will be V0. So if I draw the equivalent circuit of this particular network, so all other elements remain same. Here the network remains same as it is, but we can omit this particular element. So if we can omit that particular element, the equivalent circuit becomes this V0. Okay, and this element can be anything. It can be an R, it can be current source, it can be capacitor, it can be inductor, anything. Okay, now let's proceed further. The topic on which we will be discussing is first, that is what is open circuit. Okay, we will be discussing what is open circuit. So whenever we will be saying that there is an open circuit, that means if I draw two terminals, let's say A and here is another terminal B, open circuit means no current is flowing. No current is flowing in between these two particular nodes. No current is flowing. Okay, so this is called open circuit. So if I say that this is a particular element having two nodes A and B, and the resistance is infinite, then obviously current is 0, then it is open circuit. Similarly, if this is C, so let us understand when we can call it open circuit? What will be the value of C when it will be called open circuit? The current needs to be 0. So if I say that I equals to C dv dt, so to become I0, that needs to be 0, so this has to be 0. Okay, now let's say we are going with the inductor. It is the inductor L, and this is A, and this point is B, and this is current I. For open circuit, this is 0. To make it 0, what has to be done? So V equals to L di dt. Okay, so to make it current to 0, what has to be done? I is nothing but 1 by L integration V dt, and L has to be infinite. Okay, for this particular element to be open circuit. Okay, so the next point on which we will be discussing is short circuit, when we will say that a certain two terminals are short circuited. Okay, so what does it mean by short circuit? The short circuit means, if let's say this is one point A, and there is another point B, and if the voltage difference between those two particular point is 0, then we can say it is short circuited. Okay, so let's say if we are having two terminals A, and there is another terminal B, and in between these two terminal we are having a voltage source B which is 0, then we can say the equivalent uh, thing is nothing but a short circuit. That is, the voltage is 0, there is no voltage drop in between these two terminals. Okay, now let's say what will be the conditions of different elements to make a short circuit. So let's say two points are there, A, and there is one point B, and we are having a resistance R in between. To make it a short circuit, we know that is equation V equals to I into R. To make it 0, R needs to be 0. Okay, now the next element is we can say capacitor. So if this is one capacitor connected in between two terminals A and B, and the capacitor is C, so what should be the value of capacitor to say that point A and B are short circuited? So if I write down the equation here, we can say I is equals to C dV dt. Okay, now V equals to 1 by C integration I dt. So to make it 0, the capacitance value needs to be infinity. Okay, the next important point is that inductor L. Okay, and let's say in between two terminals one inductor is connected. So what will be the condition of this particular L, so that we can say this one is short circuited? So for short circuit, we know for inductance V equals to L di dt. So for V to 0, L has to be 0. Okay, so if this is 0, we can say this is short circuited. Okay, now another important topic on which we will be discussing is the control sources. So what are the different control sources we are having? So first, the control source which we will be having is first one is the voltage controlled voltage sources. Voltage controlled voltage sources. The next one is that voltage controlled current sources. Third, we will be checking or we will be seeing current controlled voltage sources, and last one is current controlled current sources. Okay, so first we will be discussing one the first thing, the first control sources which we will be discussing is voltage controlled voltage sources. So let's say this is a particular circuit, the terminal is having a voltage Vx. Now this particular voltage is controlling another voltage source, okay, like this, K into Vx. So this voltage source is controlled by this particular voltage. So that is why it is called voltage controlled voltage source. Okay, and here you can say this particular element, it is a dimensionless. It is nothing but a number. It is a dimensionless element. The next topic, the next control source is voltage controlled current source. The next topic is voltage controlled current source. Now if I write down, or if I depict it, so you can say there is a Vx. Now this, there will be one current source like this, and this particular current source will be controlled by this voltage. This particular current source is controlled by this voltage, and you can see, to make it this is a voltage. Okay, now to make it a current source, okay, to make it a current source, this particular thing is having the dimension of conductance. Okay, and this is called transconductance. This is called transconductance. This is called transconductance. And the important parameter or important point with respect to those voltage control current source, or previously what we have discussed, voltage controlled voltage source, these are all linear elements. That means they all obey superposition principle. They all obey superposition principles. Okay, they all obey the superposition principles. Now next topic, another point which I would like to introduce, or which I would like to mention here, is that whenever there is any controlled voltage source, it depicts like this way. Okay, like this or this. If it is a voltage source, then it will be like this and if it is a current source, then it will be like this, a diamond shape thing. The symbol is like this. Now the third point, the third is current controlled voltage source. So here the thing is like that. Let's say this is one element or circuit, and in this particular branch the current Ix is flowing, and here one voltage source is there which is fully dependent on this particular current. So this voltage source is fully dependent on this particular current. So here you can say that this is having the unit of resistance, and it is called trans resistance. It is called trans resistance. Okay, this is called trans resistance. Now the last controlled source is current controlled current source. Okay, so how this particular current controlled current source looks like, so this is a branch of a particular circuit where the current is going like this. It is Ix, and it is controlling another current source. It is controlling another current source, and this value is k into ix. So you can say that this is a unitless constant. It is nothing but a number. It does not have any dimension like transconductance or transresistance. Okay. And another important thing is that this is also a linear element. That means superposition is maintained, compliant. Superposition is compliant. Okay. Now the another important topic which we will be discussing here is the power and energy. Okay. So we need to understand whenever a particular element is absorbing power, it will be called a passive element. If a element, let's say it is an element and it is absorbing power, then it is a passive element. That is, it is not generating any energy. And this particular element, when a particular element is delivering power, then it is an active element. That is, it is supplying energy or power to the circuit, supplying power to the circuit, to the network. Okay. So let us draw a certain element and repeat a certain concept which we have already discussed. This is one certain element, and if this is the voltage across the element, as per the passive sign convention, the current I will be positive when the current direction is like this. Okay. If the voltage across the element is like this, that is in the upper portion it is positive, in the lower portion it is negative, and if the current direction is from positive to negative, then we will say that this particular so we can say or what then this particular I is going into a passive sign convention. This I is positive with respect to the passive sign convention. Now what is power? Power is, if we define pt, that is which is changing with respect to the time, as the voltage and current also changes with respect to time, power is vt into it. Okay, power is vt into it. Now if p greater than 0, then the element is absorbing power, and if p less than 0, then it is delivering power. So in this case, when the element is absorbing power, it is a passive element, and when it is delivering p greater less than 0, the element is delivering power, then it is active element. Okay. Now from this power, how to derive the energy? The energy delivered by a certain element, that is active element, will be from T1 to T2 is Pt into dt. So we can write is T1 to T2 Vt it dt. Okay. Now we will be discussing the equations, or we will be finding what is the equation for power and energy in different elements. So first we will start with resistance. First we will start with resistance. Let's say we will be starting with resistance. So the equation is V equals to I R. Okay, now the power PT is nothing but V into I, and if we put the value of V, then we are getting IR into I, then it is becoming I square R. Okay, this is the equation for power. And also if I write it in a different way, then we can say V is there, V divided by R. Instead of I, we are writing V divided by R, then we are getting V square divided by R. This is also the equation of power, which is being absorbed by the resistance. Here, because of this square term, you can say R is always positive, and because of this particular square term, this is always positive. So P, power, is greater than 0, that is resistance is always absorbing the power. So that means the resistance is an passive element. Resistance is a passive element. Okay, so we got that one. Now we have to find how the energy equation be like for the resistance. So for resistance, energy equations will be T1 to T2 and PT dt. So we will be saying that T1 T2, instead of P2 we will be writing I square divided by R, sorry, I square R dt, or we can also write it as integration T1 to T2 V square divided by R dt, and energy is also positive because of this square term. Okay, now we will be discussing how what is the power uh, equation for capacitor and what is the energy equation for the capacitor. So with respect to the capacitor, I can say I equals to C dV dt. The power PT is V I, so I can write C V T in place of I, you can dV dt. So this is the power equation. Okay, now I have to check whether this particular capacitor is passive element or active element. So let us have voltage with like this. The voltage is increasing like this way. So if I say V is greater than 0 and dV dt, so the tangent here, the tangent is also greater than 0. Okay, so if I say that V is greater than 0, dV dt is also greater than 0, and also the capacitance is also greater than 0, so you can say the power PT is greater than 0. That means the capacitor is absorbing the power. That means capacitor is a passive element absorbing power. So capacitor is a passive element. Okay, now if I having a different voltage waveform like this, so here you can say that dV dt is less than 0 and V greater than 0, so power is becoming less than 0. That means if the voltage waveform is like this, in that particular case the capacitor is becoming active element. Okay, the capacitor is becoming active element. It is not now a passive element. Okay, now we will be finding out what will be the energy, what will be the energy delivered to the capacitor, the energy equation for the capacitor. Energy equation of the capacitor. So how to find out the energy equation of the capacitor? So for energy we know it is 0 to t pt dt. Okay, now 0 to t pt vt into I t dt. Okay, now next point is 0 to t, instead of it we will be writing c dv dt vt dt. Okay, now the equation is like this: 0 to t c vt of dv. Okay, now if I integrate, then it becomes c by 2 v square t 0 to t. Okay, so it is coming 1 by 2 c v square t minus 1 by 2 c v t0 square. Okay, now if I go further, we can say the initial voltage is 0. Let's say initial voltage is 0, then the energy which is stored in the capacitor is of c v square. Okay, the final value, that is, or vt, the final value, the final voltage. Now the next element on which we will be discussing is the inductor. Now the next element on which we will be discussing is inductor. So the power equation for the inductor is like this. The power equation for the inductor is like this. In place of V, I will be say L I T T D T. Okay, so we will be depicting different conditions here. When I greater than 0, di dt greater than 0, power is 0, passive element. When I greater than 0, di dt less than 0, power is less, active element. When I is less than 0, d dt of I is also less than 0, power is greater than 0, then passive element. Similarly, I less than 0 but d dt of I is greater than 0, then power is less than 0, then it is an active element. Okay, so the next thing what we derive is the energy equation which is stored in the inductor. Okay, so for energy equation it is pt dt. So what we can write, in place of pt we can write L I d dt I dt. Okay, so here again we can write 0 to 2 integration L I di Okay, and if we go further, we can write half L I T square 0 to T. Okay, again if we go further, half L I final value square minus half L I initial value square. If I say the current initial value is 0, then the energy equation is becoming half L I final square. Okay, now the next topic on which we will be discussing is we need to check whether a voltage source is passive or active element. We will be discussing like this way, that whether it is absorbing power or delivering power or not, and we will find out the energy equation of a voltage source. Okay, so first of all, we draw a voltage source here. This is a voltage source having V0 voltage, or you can say yes, V0 voltage, and with respect to this, we say the positive current direction will be like this with respect to the passive sign convention. Okay, now we need to find out, or we need to draw how the VI characteristics of the voltage source. The VI characteristics of the voltage source is like this. So you can say that this characteristics is falling in first and fourth quadrant. In the first quadrant, always I is greater than 0 and V is greater than 0. Okay, and in this particular quadrant we can say the V is greater than 0 and I is less than 0. Okay, so whenever this falls under this quadrant, it is absorbing power, and whenever this is here the P equals less than 0, it is an active element. So now let's see why this is happening, why when this voltage source is absorbing power. Okay, uh, let us draw the voltage source again here. So let's say a series resistance is connected here. So when this particular voltage source will act as active element, when it will deliver power to resistance, obviously when current is like this way, that means the current direction is this, that means I V current is falling is particular zone. But when the voltage source connected to maybe some element, I don't know what this element is, but the current is flowing in this direction, that is current is positive, I is positive, it is falling in this region, it is absorbing power, this particular voltage source is absorbing power. So whenever the Vi is falling in the fourth quadrant of IV characteristics of the voltage source, then only it is delivering power, then it is active element. Okay, and the energy equation for the voltage source, is like this: 0 to T P T dt. Here the voltage is It's a constant, V and I is varying, then it will be like this. Okay. Now the next element to which we will be looking at is the current source. So let us draw a particular current source. How the current source looks like? The current source looks like this. Okay. And with respect to the passive sign convention, the voltage should be like this, because I am showing current in this particular direction. If this has to be positive, the voltage has to be, the positive voltage means this is plus, this is minus. The passive sign convention, this is very important, passive sign convention. Okay. Now we will be drawing the IV characteristics of the current source. This is I, this is V. So if I draw IV characteristics, I is like this. Whatever be the voltage, the I is fixed. Okay, so the I, the characteristics can be this one, or it can be like this. Okay, either the current is positive, it is I is positive, V is positive, or I can be negative, but V can be positive. Okay, so let us draw the four quadrants again. Okay, like this, and if I draw different things, so maybe this one, here it is I, here it is V, and let's say I'm drawing like this, so this is minus. So different quadrants are here. What is the condition here? I is positive, V is positive, so P positive. If I stick here, then I is negative, V is positive, P is negative. So here it is passive element, here it is becoming active element. Similarly here I can say I is positive, V is negative, then P is negative, active element. Similarly, if I draw, if I think this third quadrant, here what is happening? I is negative, V is negative, so P is positive, that means it is a passive element. Here the current source is acting as passive element. So, similarly, what will be the energy delivered or absorbed by the current source? If we have to draw that, if we have to find out that, then it will be energy absorbed by the current source will be 0 to T P T dt. Okay, so 0 to T, V is something, if I is constant, dt, that will be the energy equation for current source. That will be the energy equation for the current source. Okay, that's all for today.